Welcome to this online training about migrating to the Intel Quartus Prime Pro Edition software. When you are done with the training, please use the link provided in the registration email you were sent to provide us feedback on the training and ways in which it can be improved. This training focuses on the steps involved in migrating an existing Intel Quartus software design to the Pro Edition of the Quartus Prime software. To that end, you'll learn about the different migration paths possible between the different Quartus software products. You'll also learn the details involved in successfully migrating a design, the changes required to project assignments, timing constraints, tickle scripts, IP cores, and other parts of your design will be discussed, and explanations for why the changes are required will be presented. Here is the agenda for this training. I will go over some of the Intel Quartus Prime Pro software features that do not exist in Intel Quartus Prime Standard. I will then take a look at the Standard to Pro migration steps. Let's take a look at some Pro capabilities that do not exist in Standard. Probably one of the more recognizable differences between Pro and Standard is the Compilation dashboard. The Compilation dashboard highlights that the fitter in Pro is now broken up into stages: plan, place, and route. For Intel HyperFlex architectures, there is also the retime stage. There are other tasks that are not critical for the place and route process of the fitter, such as timing analysis sign-off, power analysis, assembler, EDA netlist writer, and the fast-forward timing closure recommendations. Each of the stages has its own play button to be able to run that particular stage as desired. I will briefly talk about the stages of the fitter in the following slides. During the plan stage, I/O placement and routing, clock resource selection, and Intel Aria 10 and Cyclone 10 clock floor plans are done. During the play stage, core resource placement of logic elements, registers, DSP blocks, and RAM blocks are done, and the clock floor plan for Intel HyperFlex FPGAs is done. Routing connections are made between all of the placed elements during the route stage. The retime stage is reserved only for Intel HyperFlex devices, such as the Intel Stratix 10 and Intel Agilex 7 FPGAs. The stage will move register placement locations to locations to help balance propagation delays based on the timing constraints that you have entered for your design. This stage takes advantage of hyperregisters, register unique to the Intel HyperFlex architecture. And lastly, the finalized stage is where post-routing timing optimizations happen. The end of each stage is referred to as a checkpoint. Intel Quartus Prime Pro software also has the ability to write a netlist at the completion of each stage. This netlist is called a snapshot and can be used to analyze and optimize your design before the completion of the entire place and route flow. There is a tool inside of the Pro software that helps facilitate the snapshot analysis called the Snapshot Viewer. I will talk more about the Snapshot Viewer later. Nearly all of the icons in the Compilation dashboard act as buttons, such as modifying the synthesis and fitter settings, to accessing the compilation reports, and launching Timing Analyzer, or the Netlist Viewers. The button in the red circle is the RTL Viewer, which will give you a schematic-like view of what your RTL is like, whereas the other buttons will give you a schematic view of the actual FPGA resources that you are using in your design. These empty boxes are optional to the flow. If you wish to run these stages as part of the entire compilation process, just check the boxes, and these buttons will launch the Snapshot Viewer that I referred to earlier. Let's talk a little bit more about it. Here I have launched the Snapshot Viewer on the plan netlist. In this example, you can analyze paths that are failing timing. If the paths are failing timing during the plan stage, then the design has no hope of meeting timing when the fitter is done. Also in the plan stage, you can floor plan your design if you know that you have specific needs for where elements in your project need to be placed. I have launched the Snapshot Viewer after the place stage. With this netlist loaded, I can still do a pre-routed timing analysis, as well showing clock resources that are being used, floor planning information, and more. In short, the Snapshot Viewer brings together all of the tools that have an ability to analyze the netlist of a particular stage. In this example, the Snapshot Viewer has run Chip Planner to generate a routing congestion heat map report. The Intel Quartus Pro software includes a new floor planning type tool called Interface Planner. You can access Interface Planner by clicking on the button outlined in red on the toolbar. The tool to use to meet the needs of placing complex I/O interfaces, following all required placement rules, is the Interface Planner. Interface Planner allows you to create legal assignments graphically using the power of the Quartus Pro fitter. Interface Planner works with the fitter to verify and validate design element assignments in real time, giving you the ability to create and complete your I/O floor plan in minutes instead of days. You can provide your floor plan to your board designer much earlier in the design flow. allowing you to have boards built with confidence knowing that the layout is correct for the device. You don't need a completed design to launch Interface Planner. All that is needed is a synthesized design that at least has your interfaces in place with some logic, so that the interfaces do not get optimized away during synthesis. With a representative design in place, you can start creating your plan on how to place your interfaces. Interface Planner will list your interface design elements in the top left panel. Information about any selected design element will be listed in the lower left panel. Legal locations are shown bolded in black in the main chip view area, and if any of those locations are used, then the area will show hash marks. You can drag and drop an interface element to a valid location in the main chip view to make a location assignment. To find the legal locations for your elements, click on the two greater than symbols next to the element you wish to place. Once that is done, the legal locations show up in the main chip view area, as we saw on the previous slide, along with a listing in the right panel of the software tool. You can also make a location assignment by highlighting the interface element and double-clicking on a location listed in the right panel. The fast-forward timing closure recommendation stage is an optional stage that exists only for Intel FPGA devices that have the HyperFlex architecture, such as the Intel Stratix 10 and Intel Agilex 7 devices. The fast-forward compiler will go through what-if scenarios of your design. The compiler will start with your design's baseline and then make speculative changes to make your design more HyperFlex friendly. These changes focus on retiming, pipelining, and optimization. Each of these stages focuses on better utilizing the hyper registers that exist in the HyperFlex architecture. The fast-forward compiler will not verify that the speculative changes that it makes are functionally equivalent, but it will generate reports on the various stages of the scenarios and the speculative changes that it made so that you can read the reports and see if the recommended changes are feasible for your design scenarios or not. It will be up to you, as the designer, to verify functional equivalency. As part of this at-a-glance section, I will also talk a little bit about the differences between Platform Designer and the standard version versus the Pro version. When using standard Platform Designer, you work with the QSys file to create your system. The QSys file contains all the information required to generate RTL code for the system, including all component connections and IP and interface parameters. In Platform Designer Pro, you still work with a QSys file, but the file only contains component instantiation and connection information, just the information required to generate the interconnect fabric, essentially turning all components in the system into black boxes. In Standard Platform Designer, anytime you change any system or component parameters or connections, the RTL code for the entire system must be regenerated. This can take some time with large system designs. In Platform Designer Pro, component information, which is just mentioned, is not stored in the QSys file, but is stored in separate IP files for each component. Component parameter changes that do not affect the interconnect design can be made in the IP file, and new RTL code for just the changed component can be generated without regenerating the entire system. In Standard Platform Designer, every component in the system must be complete and well-defined, otherwise the system can't be generated. This includes complete RTL code, completely defined standard interfaces, and hardware TCL files, which are especially required for custom components. In Pro, components do not need to be complete in order to generate the system. A generic component that defines the interface connections to the rest of the system without a functional implementation is all that's required. This works well for a team-based design or any system design where part of the system may still be under development. Finally, the Standard Platform Designer interface makes it easy to quickly create, edit, and generate system RTL code. However, with large system designs with lots of components or subsystems, the tool could slow down because the single QSys file is used for everything. With the change to separate IP files and updates to the Platform Designer graphical interface, the tool still has the same ease of use, but all aspects of the tool are faster, from simply starting Platform Designer Pro to making connections and generating output. I will now go over migrating from Standard to Pro. There are 3 versions or editions of the Quartus Prime software: Lite, Standard, and Pro. The Lite edition can be downloaded and used without a license, but it has limited device support and does not include all the features of the other editions. The Standard edition requires a license beyond the initial 30-day trial period and supports all existing Quartus features and tools and device families, up to the Intel Aria 10. The Pro edition includes a rebuilt synthesis engine and enhanced tools for working with Intel's most advanced FPGA devices. Going forward, the Pro Edition only supports ARIA 10 and newer devices. Moving an existing design from the other editions of the Intel Quartus software is the focus of this training. For a detailed comparison for all of Intel's FPGA design software, click the link listed in the slide. While there, you can download the software. To understand migrating between different versions of the software, it is important to understand the device support in each one. Device support for Intel Quartus Prime Lite Edition is listed here. Note that currently, Intel ARIA 10 devices are supported in both the Standard and Pro editions. The Pro edition supports Cyclone 10GX, ARIA 10, Stratix 10, and Agilex series. Migrating an existing Intel Quartus project to the Quartus Prime Pro edition consists of three main steps. First, you'll update project assignments and other related constraints and scripts, such as SDC timing constraints, to work correctly with the Pro edition. Note that in most cases, you'll only need to open an existing project in the Pro edition and recompile for it to work. However, this first step may be necessary depending on how your project is set up. Step 2 is to regenerate all the IP cores in your design. This includes code generated by Platform Designer. As you'll see, the software makes it easy to do this. Finally, you may need to make adjustments to your RTL code to be compliant with the new synthesis engine. Before moving a project to the Intel Quartus Prime Pro Edition software, it is recommended to make a backup of your project directory and associated files. This is a good design practice in general, but you may want to create an additional backup specifically for the migration. You can do this manually or use the project archive or project copy features found in every version of the Quartus software. When working with projects in the Quartus Prime Pro Edition software, be sure to keep project files separate from those used with other Quartus software projects. Project files in the Pro Edition cannot be used with other Quartus software projects. You also cannot compile Pro Edition projects in other Quartus software products, and vice versa. So let's take a look at what is required for Step 1, the assignments and script changes that may be required when migrating to the Pro Edition. One of the main differences between assignments and other Intel Quartus software products and the Quartus Prime Pro Edition is how module instances are referenced in the design hierarchy. In other Quartus software products, assignments need to include both the name of an instantiated entity and the entity's instance name as shown in the example. In the Quartus Prime Pro Edition, entity names should no longer be used in assignments. Only the module instance names should be used. The compiler still accepts assignments that reference the entities, but they are ignored and generate warning messages when read in by the tool. As you can see in the example, referencing just the instances also makes assignments easier to read and understand what part of the design is the target of the assignment. So the action for this change in behavior is to go through your assignments and simply remove the entity names. You can do this directly in the project's QSF file or using the assignment editor. For new assignments, make sure to just use instance names. Tools in the Intel Quartus Prime Pro Edition software are now tailored around just the instance name. On the left is the Project Navigator from the Quartus Standard Edition software. The project hierarchy lists every instantiated entity and the instance name selected for that entity. On the right, in the Quartus Prime Pro Edition, only instance names make up the main hierarchy display of the project. The entities are still listed, but in a separate column. Along with QSAT assignments, timing constraints stored in SDC files may require adjustments as well. In Intel Quartus Prime software products other than the Pro Edition, timing constraints support the use of both the entity and instance names as the name of a target, similar to their use in the QSF file. Unlike with the QSF file, there are no issues and no warnings generated by the tool if entity and instance names are used in an SDC file for a Pro Edition project. No action is required. However, if the SDC file or a Tickle script that includes SDC commands performs some type of custom name processing on elements of a design, there could be an issue. In the Pro Edition, timing netlist names converted to strings through the use of certain commands do not include entity names. The return strings must be processed correctly to reflect this. The getRegisters example shown here is an example of a command that returns names from the timing netlist, specifically the names of registers in the design. The timing exception will be applied to any register named ACK in the counter entity. In this case, there is no issue due to the wildcard characters. As mentioned, the Pro Edition still understands entities and they can be used in SDC commands. Here is an example of SDC name processing that will not work in the Pro Edition. getRegisters is used again, but this time, The names of all registers are converted to strings and stored in the variable named allRegStrings. In the for-each loop, the regexp command compares the expression, which includes the counter entity name, with the current value of the loop index, keeper. regexp would return true if the expression and the string match. However, in the Pro edition, the conversion of the register names to strings does not include the entity name counter. Thus, regexp will always fail. Check your scripts and SDC files to make sure that they correctly handle these types of conversions. In general, try to use standard SDC instead of custom name processing. If this is not possible, you can temporarily re-enable the inclusion of entity names in strings using the code shown here. Wrap these commands around your script to switch to the old mode, and then switch back. Synthesizing a design creates internal signal nodes that can be referenced by project assignments. The names of these nodes are based off of the RTL design, but random characters are often added to uniquely identify each one. There is no guarantee that these names remain the same through different versions of the Intel Quartus software, and moving to the Quartus Prime Pro Edition, the name changes may be even more significant. If you have any assignments or commands that reference synthesized nodes, verify and adjust the node names as needed. The Quartus Node Finder is a useful tool for locating synthesized nodes and checking to see if their names have changed when synthesizing in the Pro Edition software. In the same vein, make sure to also check the names of any duplicated registers in your design and the clock outputs of any PLLs. These are common locations for name changes in the post-synthesis netlist. The next required assignment changes are needed if you are using Logic Lock to floorplan your design. With Logic Lock, you create physical regions on the chip and assign logic to each region. Logic assigned to a Logic Lock region will always be placed by the fitter in that region. In other Intel Quartus Prime software products besides the Pro Edition, Logic Lock regions can be non-rectangular through the merging of multiple regions. Regions can also be reserved or floating. A reserved region prevents the fitter from placing any logic in the region, other than the logic assigned to that region. A floating region is a region without a specific assigned location on the device, allowing the fitter to choose the best location based on design constraints, including resource usage and timing requirements. In the Quartus Prime Pro Edition, Logic Lock regions from the Standard Edition are now replaced with a new syntax for Logic Lock regions in the Pro Edition. An error is generated by the tool if the old style region assignments are found in the Pro Edition project settings. All old Logic Lock region syntax must be removed or replaced with new Logic Lock region syntax. The new Logic Lock region syntax is similar to old Logic Lock region syntax. They are created and managed using the same tools: the chip planner, assignment editor, the Logic Lock regions window, or through manual editing of the QSF file, so you can use all the same tools to replace old regions with new Logic Lock regions. However, there are a number of key differences. First, a Logic Lock region cannot be set to floating. It must be set to a specific location in the device floor plan. Logic Lock regions gain some new features over the old region style, including control for routing through the region and the use of the reserved option on nested or non-rectangular regions. Here is a detailed comparison between the two types of regions. Logic Lock standard regions gain full support for selectively including or excluding periphery resources. This includes a new core-only option which completely excludes periphery resources from the region. With Logic Lock standard, placing a region inside another region didn't do much since this nesting did not match up with the design hierarchy. Logic Lock standard matches up physically nested regions with levels of logic in the design hierarchy. Logic Lock standard regions have limited support for reserving nested or non-rectangular regions. Also, reserved Logic Lock standard regions cannot cross I/O columns in Intel Aria 10 devices, requiring the region to be split. These limitations are removed in the Pro Edition. If the core-only option is enabled, a reserved Logic Lock region can cross the I/O columns without affecting any periphery logic. Another feature is the ability to set a region as a routing region. The routing region must encompass the existing Logic Lock placement region. Logic Lock standard regions also do not require additional naming. They take on the name of the logic assigned to them. You can have multiple instances of the same logic in a region, but currently, this is only in non-reserved regions. This may change in a future version of the software. Finally, Logic Lock regions do not allow for the exclusion of arbitrary logic from a region. The core-only option can do this for periphery resources, but non-rectangular shapes should be used to exclude other core resources, such as RAM and DSP blocks. As mentioned, the same tools are used to create and manage logic lock regions. Other than the new button, you can create logic lock regions in the chip planner in the same way as before by simply clicking and dragging to draw the new region. The logic lock regions window looks different. As mentioned, regions now get a name based on the logic assigned to the region. If no logic is assigned yet, the region is named unassigned and does not get written to the QSF file. New Logic Lock Pro Edition regions are set to reserved off by default. The new core-only and routing region columns enable those features as described earlier. Logic lock assignments in the QSF file are much simpler than the Logic Lock Standard Edition region assignments. A single assignment specifying the logic assigned to the region and the lower left and upper right XY coordinates of the region are all that's required. Logic Lock Standard Edition regions require separate assignments for all this information. In the example shown, you can see that the ABC logic is constrained to a region whose lower left corner is at 1010 and whose upper right corner is at 2020. Non-rectangular regions can also be created in a single assignment. Simply add additional sets of 4 numbers, representing the coordinates of each additional rectangle, to the assignment. Even if the coordinates overlap, the rectangles will be merged into a single region. As mentioned, nested or overlapping logic lock standard regions match up with the design hierarchy. Because of this, overlapping regions restrict the placement of lower-level design instances. These child instances are constrained to the region of their parent. If a region constraint is added to the child, this constrains the placement of further lower-level instances. In the example shown here, ABC is constrained to the region in the upper right. Without any additional constraints, all logic for ABC and any lower-level logic, its children, would be constrained to just this region. A second region constraint is added for ABCD overlapping the first region. Now, ABCD logic can be placed in the area of the second region outside of the original ABC region. However, since the two regions overlap, any child instances of ABCD are constrained by ABCD's parent. Thus, logic, such as ABCD, would be constrained to the intersecting region. Be aware of this when recreating your floor plan with logic lock regions in the Pro Edition software. It is perfectly legal to place instances of unrelated logic in the same region location. The first example illustrates this. Of course, the region would need to be large enough to contain the logic from both instances. However, if a region is reserved, overlapping regions are not allowed, and the tool generates an error. In the second example, the ABC region is now reserved, so the EFG region cannot be placed on top of it. What if in the previous example, the second region only partially overlapped the reserved region? In this situation, logic for the non-reserved region can be placed, but it is constrained to the area outside of the reserved region. In the example shown here, the EFG region has been extended out past the reserved ABC region. Doing this allows for placement of the EFG logic in the area outside the overlap. When migrating to the Pro Edition, signal tap files may also require changes to work correctly. Recall that entity names are not used when creating assignments for logic in the Pro Edition. In a signal tap file used to create one or more instances of the signal tap embedded logic analyzer, design nodes are tapped for building trigger conditions and for capturing signal levels when the trigger conditions occur. Entity names must be removed from these tapped nodes. To do this, use the node finder to quickly find and remove nodes that include entity names. Run analysis and elaboration, the first stage of synthesis, to rebuild the node database, and use the node finder again to add the nodes back into the file. If you are tapping post-fit nodes for the logic analyzer, these must be replaced as well. The post-fit node naming scheme is different between other Intel Quartus software products and the Pro Edition. Again, use the node finder to find and remove the post-fit nodes. Perform a full compilation, running the fitter, to recreate the post-fit netlist. Now use the node finder again to add the desired post-fit nodes back into the STP file. You can also just perform a full compilation in the Quartus Prime GUI or run Quartus_STP, the signal tap command line executable, to remove signal tap assignments that were created in other Quartus software products. There are a few additional assignments that should be adjusted or removed when moving to the Pro Edition. If you have any assignments that are used for the incremental compilation feature, these must be removed. Incremental compilation, the ability to break up a design into design partitions, and then choose which partitions get compiled during subsequent compilations, is not supported in the Pro Edition. Remove any assignments used to create design partitions, Set the netlist type to be used for subsequent partition compilations, and any netlist preservation settings. The second step in the migration process is to regenerate all IP in the design. When moving to the Intel Quartus Prime Pro Edition, the files for all IP cores and Platform Designer system designs must be regenerated. When you first open a project in the Pro Edition, created in another Quartus software product, if there are any IP cores or Platform Designer systems in the design, the top of the project navigator will indicate that IP upgrades are required. To regenerate the files, you can reopen the IP parameter editor for each IP core and regenerate them individually, or use the Upgrade IP Components dialog box to quickly regenerate all IP. You can access this dialog box from the button that appears in the project navigator or from the project menu. Click Perform Automatic Upgrade to regenerate all the IP. The Upgrade IP Components dialog box should also be able to regenerate any Platform Designer system designs in the project. If you encounter any errors during this process, open the system's QSys file in Platform Designer and regenerate the files there. So why is it necessary to regenerate IP when migrating to the Intel Quartus Prime Pro Edition? Besides the usual reasons for regenerating IP when moving to a new version of the software, such as updated and enhanced timing models, the Pro Edition uses a new scheme for IP core management. In other Quartus software products, a proprietary Verilog configuration scheme is used in the top level of all IP cores and Platform Designer system designs. This is used to prevent ambiguous instantiation errors during synthesis that can occur due to instances with identical names or multiple instantiations of the same instance. While this configuration scheme works for synthesis, problems may still arise during simulation, requiring a user to implement their own fixes, including the creation of a separate configuration, deleting duplicate design entities, and renaming identically named entities. In the Pro Edition, this proprietary configuration scheme is not used or supported for IP or Platform Designer systems. Instead, all variants of a particular IP core, even if those variants are configured identically, are compiled into the same library location for the entire project. For example, every instance of the Intel Aria 10 PCIe IP core is compiled into a library named Altera_PCIe A10HIP_151. This prevents errors because all instances use the same file sets from the same location. This also eliminates issues with simulating the design because both the synthesis and simulation file sets instantiate design entities identically. Finally, the file directory structure for IP cores now matches the compilation library structure, making it easier to understand how IP files and compiled project files are organized. To learn all about the optional and required code changes when moving to the synthesis engine, see the free online training, Using the Synthesis Engine in the Quartus Prime software, linked here. This concludes our look at how to migrate to the Intel Quartus Prime Pro Edition software. To get more information about the migration process, see the Migrating to the Quartus Prime Pro Edition chapter in the Getting Started User Guide. Intel Quartus Prime Pro Edition, linked here. Here are some classes freely available if you wish to become more familiar with the Pro version of the software and its supported devices. The last link is to the training page so you can browse through the many classes that we have to offer. Intel provides multiple avenues in which to learn about Intel FPGA products. There is the Intel FPGA YouTube channel, which contains 5-minute quick videos along with longer, more in-depth training videos. There is the Intel FPGA training website, where you can access e-learning courses made up of narrated slides presented in an interactive player, some courses with labs and demos. Lastly, you can also enroll in a live, instructor-led course presented either in person at an office local to you or virtually over the web. All instructor-led courses have hands-on labs exercises to practice the concepts you learn. If you need more assistance, Intel FPGA provides many self-help resources for you to access. For example, there are web pages called landing pages dedicated to specific FPGA technology like and high-speed interfaces. You can also view and post questions to the community forum, which is monitored by skilled Intel FPGA applications engineers. The Intel FPGA training team is always looking to improve our material and welcome any feedback you may have. Please email fpgatraining@intel.com with any of your thoughts or comments. This concludes the training. Thank you and have a good day.